All right, let's just think about this for a second. It's something we do dozens, maybe hundreds of times a day without even thinking about it. We click a link, and bam, in less time than it takes to blink, a whole new world just appears on our screen. It honestly feels like magic. But what's really going on is one of the most complex, high-speed dances in the modern world. So today, let's pull back that curtain and take a look at the invisible journey. So you see a link, you click it, and poof, the page is just there. But what is actually happening in that tiny fraction of a second? We're going to follow a single click, a single request on its own little hero's journey from your computer out across the huge digital ocean of the internet and all the way back home.
Yeah, from our side of the screen, the whole process seems super simple, right? We click, maybe we see that little spinning wheel for a hot second, and then bam, there's our content. But underneath this simple little three-act play, there's an incredibly sophisticated story going on. So let's break it down. So every great adventure has to start somewhere. And for our little piece of data, its first big challenge, its call to adventure, is basically a translation problem. See, before it can even think about starting its journey, it has to know exactly where it's going. And it turns out computers and people speak very, very different languages when it comes to addresses. We humans, we remember nice, easy-to-read names like www.explainer.com. But computers, on a network, they couldn't care less about names. They find each other using a series of numbers called an IP address, something like 128.208.2.151. It's a classic case of what's easy for us versus what's efficient for the machine.
And that's the big question, isn't it? Your browser has a name, but the network absolutely needs a number. So there's got to be some kind of universal phone book, right? A massive address book for the entire internet that can handle this translation.
Well, lucky for us, that address book does exist. Before our data can even be sent, your computer has to check this massive directory to find the right numerical address for its destination. This is the first and maybe most critical step to finding the way.
And that address book is called the DNS, or the domain name system. The moment you click a link, your computer sends out a quick message with a website name to a DNS server. That server looks it up in its huge, sprawling database and sends back the IP address that matches. Now that we have the number, our journey can really begin.
Okay, we have our destination address. We know where we're going. But you can't just send your request out into the world unprepared. No, just like you'd pack for a trip, the data needs to be properly broken down, labeled, and organized so it can survive the journey ahead. At its core, what you're sending is a really simple message. It's a request that basically says, hey there, server at the specific IP address. Would you mind sending me the stuff on this webpage? It's just a small piece of data, but it has to be packaged perfectly.
Now here's where it gets really clever. The internet doesn't try to send information in one giant, clumsy chunk. Instead, your request and the web page you get back gets chopped up into these small, easy-to-manage pieces called packets. It's kind of like sending a book one page at a time. It's just way more efficient and reliable that way. So you might be wondering, with all these different computers all over the world, made by different companies, how do they all agree on how to format these packets so they can actually understand each other? Well, they use a protocol. And a protocol is really just a shared set of rules, a common language that decides how data gets packaged and understood. For this part of the trip, the most important protocol is called TCP, the Transmission Control Protocol. And you can think of TCP as the most reliable, detail-oriented courier service you can possibly imagine. It takes all those little packets, it slaps a sequence number on each one, and then on the other end, it double-checks to make sure every single one arrived safely before it puts them all back together in the right order. In short, TCP is all about guaranteed delivery. Okay, our packets are addressed, they're all packed up, and they are ready to go. Now, the really incredible part of the journey begins, a super high-speed relay race across the internetwork, this huge global collection of interconnected networks. So your computer, that customer PC over there on the left, it's just sitting on your little local network at home or at the office. To get a message out to the big wide world of the internet, its packets have to be sent to a special guide first, a device that knows how to connect your small network to the much, much bigger one. And that guide is called a router. You can think of routers as the traffic directors of the internet. Their whole job is to connect different networks. When a packet shows up, the router glances at its destination IP address and makes a split-second decision about the best path to send it on next, to get it just one step closer to where it needs to go. And this is where the sheer scale of the internet just becomes totally mind-boggling.
Your little packet might have to jump between dozens of these routers to get where it's going. And at every single one of those jumps, the router has to choose from potentially millions of paths. How on earth does it make that choice so incredibly fast?
Well, it uses a routing table, which is basically a set of digital signposts. Now, here's the clever part. A router doesn't need to know the entire path from start to finish. It only needs to know the very next hop. It just looks at the destination network in the packet's address, finds the right entry in its table, and that table tells it exactly which neighboring router to pass the packet to next. So after hopping from router to router, maybe bouncing across continents and under oceans, our packets finally arrive at their destination, the web server. But the journey is only half over. Now, this whole amazing process has to happen all over again, but in reverse. So the server gets all the reassembled packets. It understands you're asking for a web page. So it grabs all the content, the text, the images, all of it. And then it does the exact same thing your computer did. It breaks it all down into a brand new set of TCP packets. And this time, each one is addressed to your computer's IP address. And now, those new packets, the ones actually cherrying the web page you asked for, they begin their own journey home. They travel back from the ISP server, hopping from router to router, finding their way all the way back across the internet, right to your front door. And here, my friends, is the grand finale. It's time for reassembly. Your computer's TCP protocol starts catching all these incoming packets, and it doesn't even matter if packet number 3 shows up before packet number 1. That's okay, because TCP checks all the sequence numbers, puts everything back in the correct order, and perfectly reassembles the web page. Only when it's whole and complete is it handed over to your browser to finally appear on your screen.
And just think about it. All of that, the DNS lookup, the chopping into packets, the journey across the globe, the reassembly, it all happens, quite literally, in the blink of an eye. It's this incredibly complex and resilient system, performing this digital dance billions of times every second. Which, of course, makes you wonder, in a system this complex, what happens when just one tiny piece of that puzzle breaks? Well, that sounds like a story for another explainer.